We're gonna start chapter 3 still, but it's 3.5.
Go down.
Yeah?
Go down.
Pappus Theorem.
Huh?
Have you heard of this?
No.
What?
Pappus Theorem.
You're a papa.
So, let me just read the book. So we come now to one of the most important theorems of plane geometry.
Wait, what? This is the most.
I guess the reason it's important is because it's like the first of a result that started a new branch of geometry, okay, called projective geometry.
What's projective?
What we're about to learn.
One way to think about projective geometry, I mean, like we do 2D geometry, right?
Yeah.
Well, another way to have 2D geometry is to have like 3D geometry projected onto 2D. So that's like how we see the world with our eyes, right?
But why would you do that?
Because that's how we see the world with our eyes, right?
Oh.
Yeah. So the point, like, for example, like parallel lines, right? The point is they don't meet. Yeah.
Yeah.
But when you look at, have you ever seen two parallel lines that don't meet?
Yes.
It's like if you look at the road, right? It doesn't look like they don't meet,
Oh,
yeah?
At the horizon.
They meet, yeah?
Kind of.
So that's kind of like one of the points of projective geometry. And when parallel lines meet, then there's kind of like a duality between lines and points.
The roads, like, they're not perfectly parallel.
Anyway, so let me just talk.
Anyway.
So it was first proved by Pappus of Alexandria about 300 AD, but its role in the foundations of projective geometry was not recognized until nearly 16 centuries later.
Pappus has properly been
Yeah,
called.
you could read
Why did he do this?
Huh?
Because he's a big brain. Because he wanted us to study him.
It's kind of it's a pretty natural.
That's like all textbook
You know,
people.
when you study...
So with maths, like a lot of people when they work on maths, pure maths, they do natural stuff. They're not necessarily out to solve a problem, you know?
Oh.
They're kind of just seeing like natural patterns and things and just kind of writing it down
You
and
were a
stuff.
hero of Alexandria.
I want to live in like 1000 BC. So
Yeah,
I
and
can
then
discover
become
all like the math.
No, you can just become a genius. Like,
Yeah,
take
but
this
see, then
book
no one
back.
will believe you because like they don't even know what it's like.
Prove it. Like.
You prove it, but then they don't follow the proof.
Yeah,
It's
right.
retarded,
Yeah, you prove it by Pythagoras and they're like...
No,
Wait,
Pythagoras.
no. After you explain it in the minutest detail that anyone can understand, right? After you do all that, and they're like following like this the whole time, then what they do? They go,
What?
oh, but is like the government agreeing with that? Like that's what they. Like,
Is
this
the
literally
church
how
agreeing with
maths is.
this?
Yeah, like it's like they don't actually listen to anything you say, and then it's all about like authority. I mean, the world's like that now. I mean,
It is.
yes.
Okay,
But
time
who
to not be
actually
a-
listens to maths people?
All right, listen up. So,
Yeah, you.
I didn't even get my
Who
next
actually listens to-
mathematician.
Pappus has appropriately been called the last of the great geometers of antiquity.
Apparently.
The particular theorem that bears his name may be stated in various ways, one of which is as follows. Okay. So you have ACE are 3 points on one line, and BDF are 3 points on another line. Okay. So let's draw a picture. So you have ACE like this.
Someday I'm gonna be diligent enough to read this. Like the
Yeah, and then that day I'll stop going through it because finally I'm trying to teach you how to read this book so that I stop reading it to you. BDF.
Why is it a couples?
Does the book have solutions in it?
No, not
It has like hints. Oh,
Wait, does?
Yeah. So I
First,
Huh.
I mean I try not to. I never look at the solutions until I've solved it.
To make sure your solution is correct.
Yeah, and sometimes I like to do a different solution to make it more interesting. So BFC.
Are you sure Eric got bad paper value? I don't think that's how it works.
Okay, so you have
Tell that it's so hard.
I don't think that's how it works though.
okay, so you have 3 points and 3 points.
Come on,
Yeah.
sorry.
Yeah, we get it.
Guys, stop it.
Oh, there is answers. Oh.
So
Oh,
okay, so if the 3 lines A, B, C, D, and E, F, okay, so A, B, C, D, and E, F. A, B, C, D, and E, F.
This is dumb. Crap. Can you put your hand down?
Meet D, E, F, A, and B, C. So
Oh.
D, E, F, A, and B, C. BC. So this is, I guess, like a zigzag.
Zigzag. Oh, gee.
Yeah. Then the 3 points of intersection.
What the hell? That's so
Oh, they're
random.
also colors. Oh, I heard
Okay,
that.
so where's AB? AB meets DE, yeah? AB.
Yeah, it's just like the 3 points.
AB.
Oh!
No!
It wouldn't even hurt if he dropped the book in you.
No, but that just like deleted my balance.
FACD.
If I close my eyes, then that's fine.
Oh, were you balancing my pencil case?
Yeah.
Oh, I didn't know that.
Just don't move. Just sleep.
Just sleep. Bro, he fucked it. What a massive man.
Yeah, so you're basically taking all the ways of intersecting this, yeah?
You need to just pull that off.
Wait.
Yeah.
Guys,
So the conclusion is
oh, don't chuck it. Yeah, chuck it.
Come on, you go.
okay, so basically if you take 3 lines on a point and 3 lines on another point, yeah?
You trying to get
And you kind of like draw all the ways you can zigzag, yeah? The 3 points that you get from these two and the last 3, yeah?
Gonna die. Oh my
That
god.
ain't legit. That ain't legit.
Oh god.
Wait, it is.
Yeah?
Cough like that.
Me.
So, stop it.
I've cried.
Yeah, okay.
Yeah.
So,
Cough like that.
Why are you making fun of how people cough, bro?
Okay,
so the conclusion is that the line is collinear. LMN is collinear.
So you think I'm not impressed?
Yeah?
Yes.
Okay?
I'm not bullying a human.
So it doesn't say here, but you might wonder why.
Bro, at one point,
Like,
when
which
the
point-
measurement
so, like-
temperature, it was 34.
Shut up! Okay?
Oh, come on.
So if you have L,
Stop now.
okay, if you have L, right, that's like ED, so that's like the farthest ones intersecting, yeah? N is like the middle one on top intersecting with the left one, and then M is like the middle one on top intersecting with the right one, yeah? So you might wonder why.
Why is it specific?
That's what I'm trying to answer you.
The middle one has to be to the right.
No, but look, this is like all the ways you can intersect it, right? The only thing that's not being joined are the ones that are like next to each other, yeah? A is not being joined to D, C is not being joined to F, E is not being joined to B, yeah?
Oh.
Yes.
So there's a strange thing about. Should there be another set of collinear points? Hold on, so if this goes to the middle, yeah? There should be another one where. So this is
Wait,
middle.
are A, E, M, N, and B, D collinear?
Where?
A, E, M, N, and B, D. Like you need
A,
one.
E,
M, N,
M, N,
and B, D.
B, D.
Like if you just extended them all. Because that would be...
I mean, any 2 points are close enough.
No, like there are 3 different lines. They don't have to be collinear.
Wait, how can
Concurrent, you mean?
Oh yeah, that's what I meant.
Probably, yeah.
Because A,
Can
E,
you
and
prove it?
Yeah.
just make like you have like A, E, and B, D aren't like parallel because they meet at
Well, they are
What's
parallel.
that?
like they're not. Or
Yeah, so this is symmetric, right? So if it's like middle and outside, the other way it's also middle and outside, yeah?
so just
That's
say
I mean,
if,
middle and
there's
middle.
3 points that
There's middle and middle, and then it's outside and outside, yeah? So it doesn't matter if that's on top or that's on top.
also it's
Ooh.
saying any 3 points which can result from.
Yeah, actually, there's lots of, apparently there's lots of, what we're going to see, there's lots of ways to draw the diagram. It's actually kind of cool, okay?
Oh,
So they're always calling.
So yeah, so the reason is called the projective, so the projective nature of this theorem is seen in the fact that it is a theorem of pure incidence with no measurement of lengths or angles, and not even any reference to order. In each set of 3 collinear points, it is immaterial which one lies between the other 2. So there's some other diagrams where you kind of reverse the order. Maybe you look at them. you can put like ACE like this way, with the E in between C and A. Okay. And still it happens. Okay. Okay. Yeah. So we're avoiding all the projective stuff here with points at infinity and stuff. Okay. All right. So there's lots of ways to prove this, but the way that the book presents is using. Well, how would you prove this? How would you think to prove it?
Angle shape like that.
Use fact.
Can you code bash it?
No, but there's no length or anything. You know, like,
Yeah. It's, you use vectors.
Vector bash.
Vector bash. What do you love vectors?
Why?
Because
so,
they're like
any ideas?
Can you no angle back? No.
No,
You
you
can't.
can't rotate the
There's
angle
no
system
angles
out
to it,
without
yeah.
creating like 27 angles.
Or you could find a good case and then do it like that.
you find a good case.
Diagram dependency.
That's
I
not
mean-
proving it if you just
Yeah.
prove one case.
I mean, in a vacuum, you might not have any ideas, right? But like, I mean, given our context, there are some natural things to try.
Use C view.
Yeah, I mean, it's not that theorem, but it's like the theorem we did today, right? Menalaus. Like, we have a theorem that tells you exactly when 3 points are collinear, right? So that might help here, okay? So I guess to make sure,
Wait, Menalaus actually works.
I guess that's what the book is claiming, you know?
Ooh.
You want to try and see how it works?
Oh.
Okay, so it starts by like, so to show Menalaus, you need to show some things times together to -1, right? So you might want to start with some things that times together -1. Okay, so for example, the book says, no, this proof is referenced in the book as well. I won't go over it.
Can we just like read it?
Yeah, where's the W though?
Huh?
I don't know. It says V.
Yeah, but if you say, can we just read it, it's kind of like, can we just do exercises at home and stuff? Yeah, you can, but like I've
But you
never seen
don't.
it happen over like
I've
2
never
years.
seen that.
Okay, so once you do it, then you're free. All right. So LDE.
No.
So LDE. LDE. So LDE is collinear, right?
Yeah.
Yeah. And so let's look at triangle WVWE. UVW.
Oh, what's W?
Okay.
Yeah, that's a good question.
It's U and where's V?
I
Oh,
don't understand.
yeah. What is U? Oh, hopefully they're not using it. No, they're using another diagram. That's annoying.
Oh, the 3 lines A, B, C, D, E, F form a triangle U, V, W.
Oh, okay. So let me just draw it in with black.
ABC,
Did this list all the points? And, yeah, that's what it says in the book.
That's like the
So
last
if you join FE, yeah.
So weird. What the hell?
Oh, so V is this point here.
I think that's good for the
So V is this point of intersection. Yeah. W is this one. Yeah. And U is the one that goes out. FE. Oh, they have it the other way around. It's kind of a little bit annoying, but
Oh.
If we don't care about the signs, it might be okay. So U is this one.
What?
Yeah?
Oh, it's like just where the red lights intersect.
Yeah. That's a good way of saying that, yeah.
Where's you?
Yeah, with the red lines in.
Yes.
Make it true now. I can even write it in red.
Whoa.
Emphasizes the truth.
Okay, so let's see. VL on LW, WD on DU, and UE on EV equals -1. Did you remember how it was? It was like XB. Do you have the book in front of you? Maybe you can share.
Sharing is caring.
Your book.
So it's BX on XC. So X was the one that was
What?
on BC, yeah?
Yours is fine enough. It looks weird.
Oh, so this is.
Mine's just big. It looks weird.
You're big.
But it was like the sides of the triangle at the front. And then on the bottom is the size of the triangle at the back. So where's where's L? L is here, right?
8VM.
So L is LV and V LW, yeah? So that's
Yeah.
inside the triangle. And then WD and DU. So D is on UW, right? Yeah. And then E is on UV. It's outside, yeah? Does that make sense?
Wait, why is EV outside?
It's just.
I mean, E is outside of VU. UV is here. So the triangle is in the red, yeah? But we're saying EDL is collinear, right?
Yeah.
Yeah, so if it's outside, it's negative, right? If it's inside, it's positive. So it's kind of positive. Well, is it? VL and LW, yeah? So that's positive. So it's positive, positive, negative, yeah? Yeah, so it's saying because ELD is collinear, we have this from Menalaus, yeah? Applied to triangle, red triangle, UVW.
Oh.
Okay?
Yes.
So,
Doesn't work if it's
upside down.
upside
Oh,
down.
bloody hell.
Ah, come on.
Stay relevant.
Did you say the H word?
Yes,
OG.
Alright, now we have AMF.
Leo.
You just said
AMF is also collinear. AMF, yeah?
I'm just. No.
AMF bowling.
Oh, come on, guys. This is so random.
Isn't that
This is
like-
bordering like
that's-
retarded, okay?
That's been replaced by Kingpin.
Okay.
Yeah, and then he carries it on. What is this? You have no control over your souls. Okay, so VA on AW times WM on MU and UF on FV is equal to -1. Yeah?
Is what? Yeah,
It's very thick.
it's hairy. It hasn't thick.
It's also thick.
It's not that thick. It's hairy, yeah.
Guys, if you don't pay attention, you're gonna get lost because there's another 3 of these.
Yes, stop it. Okay, that's thick.
You
Stop it.
Yeah, so AMF is collinear, yeah?
have.
Oh,
Yes, once.
And the thing with maths is like, why would you do it just for one of them? If you do it for one of them, you should do it for all of them. Yeah, that's kind of like, unless that one is special. Yeah. So you guys are special. Okay.
Yay!
Alright.
I
In a
love
bad way.
You don't
So
have to
EL.
say
So the
bad way. It's
natural thing to
obviously
do
a
would be
bad
like
way.
B and C is
It's
natural,
worth a
right?
joke.
BCN is a natural thing to do. Yeah.
Yeah.
Okay.
Yeah.
And so is we already did
Yeah,
EF.
only 3, yeah.
I'm still trying to follow.
Those three, and then
It's the same, but on a different
CMT, no, ACE, oh, and then ACE and BFT, okay? So the original three, the original blue lines.
It's gonna get infected.
It's a stick. Calm down.
No, yeah, that's the point, it's a stick.
Oh wait, no, mind. It's okay. It's
Okay, so VB
I'm gonna die.
on BW times WC
Wow.
CU.
This guy.
Okay?
I want to see the command from 30 and skinny.
I'm gonna bully you right now. Come on, you're the real bully. Well, this is excellent.
Okay, maybe you can kind of guess what the formula is for ACE. Maybe that would be like an easier. Huh? So ACE, what would it be?
Okay, so ACE in order
Because
for
the point of this is so you get better at Menalaus, not to let you wait till the end. Like, just trust that it's true in the end, right? Okay? Like, math's not about trust.
ACE.
So what would be the formula for ACE if you have the triangle, the red triangle, UWV?
CU. Wait, no.
Oh,
So something equals minus 1, yeah?
Yeah.
Oh no.
I'm so trash at Menalaus. It's so easy to follow, but not like reverse.
Yeah, once you ask the question, it's like... But at least you're honest. At least you're honest.
My brain. Wait. ACE.
Which red triangle? I'm still confused.
The basics.
I don't know.
I'm
what
gonna read
the actual-
Menalaus again.
Yeah, but look, it's here though,
Okay,
right?
V-
It's here.
VL.
Yeah?
That's what you do.
Look at it. The sides of the triangle is always VWU, right?
VL, that would be VA, right?
VD
Wait.
DU.
Things I don't remember the formula either, but I can see these three and figure out what it should be.
E
Is this
E-
like
E
I know.
on
Wait.
EV.
VL,
What the
VA,
Wait. I think
It's VE.
VE, did you say?
Yeah. Are you sure?
Oh, we'll check it out at the end. Okay?
I'm just guessing. What? VA.
Wait, is it? Should it be like?
VL
It should
That's
be
a
like
good guess.
E F
LW.
M.
The VE on what?
WD on
VE on U. UE.
Okay.
UE.
Yeah, wait, UE.
No, it'd be E something, right? Look.
Oh yeah, EU.
EU.
That's what I meant.
Isn't that? Oh yeah, no, it's not the same thing. We have direction.
It'd be EW, wouldn't it? Like they're all EWs. They're all W's.
Oh. Well.
Huh?
Well, I'm sorry.
Sorry.
But they're all like.
Or maybe it's another. It's actually because it's a different. It's the same triangle.
Huh?
Maybe.
Oh, it is a U this time, right?
Yeah.
Yeah, it's
Oh,
an EU.
okay.
Wait.
So you didn't get put off by the fact they're all W's.
But then it's probably VE's wrong then.
Yeah, maybe V is wrong.
Yeah.
Yeah, because
They're
the
all
other ones
they're
are
all
all U's.
V's as
And
well
the next
though.
ones are all V's. What the
that's-
hell?
But there
What
are
is
only
VA?
4 items.
Is it VA?
No, but there's already a
There's
VA.
already a
Is there a VF yet? No. VF.
There's only 4
Yeah,
items.
good. Yeah, it's VA. Yeah.
Like,
What?
What?
Well, I mean,
VA.
okay, if it's gonna be W here, then it's
Oh
VA
yeah.
Yeah.
Oh.
and AW. Yeah.
We have that.
Though, like, it's still right if you do VE. It's just gonna be one of the other terms, though. It's gonna be on the bottom,
How does this one?
and UE is gonna be the other one. Yeah.
I'm asking you.
Siri.
Hey Siri, how does this work?
So VW
Searching us spaghetti. It's like
VWU. Yeah.
The word for spaghetti.
And then, what is it? It's WUV. Yeah.
W.
Oh, so the line. Oh, okay.
Okay, so WU, right? It's gonna be
ACE.
WM.
U. It's gonna be a C, right?
Yeah. CC.
C. Yeah.
And then the other one's EE. OMG, we did it.
It's the map.
Is it correct?
The middle one is. Oh no, it's not. Wait, is it the same? No, it's not.
Yeah, see? And then now you have some command over this formula which we all forgotten already.
Whoa.
Yeah.
This formula is actually.
This formula is insane.
Alright, let's do it
But
now
we've
again.
literally used one of like
For
the other
BDF.
three. We've used VA
For
on
BDF.
W, then we've used W.
Oh, what's the formula going to be for BDF?
I believe
BD,
Yeah.
BB.
BDF. Blue line. That's why I'm running it in blue.
BF.
Oh.
Yeah.
VB.
VB. VV.
Oh, it's actually VB.
BD.
Is it?
V, who's saying V something?
It's VB.
VB.
According to Carl.
And then
Alright.
WB
Yes.
or
What?
BW.
BW.
BW, sorry. Oh my.
Ah, yeah, it's
Oh, wait, it's actually VB.
Huh?
Yeah,
Yeah,
VB,
it was VB.
So then it's WD. No.
What?
Hey, it is WD.
WD.
WF somewhere.
Yeah?
Yes.
C.
WD.
I'm not going to write.
UD. Odd.
UD?
UD.
Come on, guys.
Wait, what?
EU.
Oh,
Oh,
why is
that's
it
what I meant.
directional?
That's what I meant.
Why is it direction? Why does it change anything?
Alright, what's next?
Oh, brother.
What?
I thought of the next one.
Alright, so U.
Wait, I forgot UF.
What?
Yeah.
Where is it FV?
Yeah.
Is it on FV? Yes. You know why? Because that's the only combination that
Ah, good
you got third, first, top,
Okay.
second, the first, second,
Okay.
and then third.
It's actually
Good job, Boomer.
I think like there's one more that we can do.
Oh. I shouldn't even read the next sentence
Is
here.
it VL?
No.
Wait, what are you talking about?
Come on, stop.
Please, I don't
It'll create a third line.
Alright, okay, guys, can we state one thing before I go insane? Okay, so, alright, what is the result that we're trying to prove? So we have all the facts we need to know now to
And
obtain.
is calculating.
We absolutely used everything, right? What's the thing that we actually want to show is
LM.
NLM collinear.
yeah, NLM collinear, right?
That's what I said.
So what? I mean, okay, what would be formula for that?
Oh, no.
It was the third one. It was the third one you just said.
Yeah, it's VL on LW, WM on MU, and then UN on WV.
on LW.
Yeah, good job.
What is it?
WM on MU.
WM on MU.
Yeah, and then UN on WV.
UN on WV.
No, W.
WV. They're on the same triangle here. WV. This is wrong.
Ah.
WN.
It's whatever that says then.
Yeah, well, what's the bottom one? It's WV. The bottom one's WV.
Wait, WM on
that's an
MU
N.
and then U.
Actually, you're so. It's just whatever that says.
Okay, then it's NV.
Envy. In green.
NV. Wait.
Okay.
NV.
So VL and LW are looking good. WM on MU.
That's
Yep.
legit. That's legit.
UN
That works.
on NV. Okay, that's so the green is what we're trying to show. The blue and red are what we had. Yeah.
Ooh.
Red.
Wow.
Ah, red.
You times them all together.
Yeah.
That's how it works. That's how it
Wait,
works.
what? Wait,
You times all 5 equations together.
Okay, Leo.
Yeah, Leo can do that.
Leo, you
Nah,
can do that. We have a volunteer.
Wait, no, that actually won't work.
We have a victim, not
Alright.
a volunteer. Same thing.
Okay, Pumbaa.
Look at
The way he says boomer.
Dude,
Who said that?
I asked.
I
No.
did I ask?
Yeah, I asked.
Hmm.
How to do this?
Just times 2 of them together and you get +1.
Dude, I
What to do?
asked.
It is.
Alright, okay, let's look at where these things come from, okay? This is not in the book, obviously, but use common sense. So this VL on LW is here, yeah?
Yeah. That's literally where we got it. That's where I got it from.
Could you just try multiplying like
WM on
One,
MU
one,
is
one.
here, yeah?
Yeah, just multiply 2 of them and you get 1.
no,
See
multiply all 3 of them and then just take them out by dividing by that?
Oh,
Oh.
smart boy.
See, this is the 3 that you need, right?
So you
Yeah,
multiply them together.
that's that one.
Yeah, see, oh, that actually works.
And then you divide it by that. Those two.
Smart kid.
Oh, then
Okay,
you
so
don't.
these 3 are the ones that you want, yeah?
Yeah.
Yeah.
Oh, then you actually don't.
And the other 6 are
You
like
get
from
cancelled by
the
the from the top.
They're just there to help you cancel
because
stuff.
they're all the
yeah.
same terms anyway.
So you actually do technically multiply. No, you only
Yeah, you multiply 3 and
Three and
divide.
divide.
Okay, so you multiply all this, yeah?
Yeah.
You get -1, yeah?
Yeah.
And then you get the 3 terms you need, yeah? And you get like 1, 2, 3, 4, 5, 6 terms you don't need, yeah?
So you don't have a
Which are also equal to 1.
Yeah.
Okay, but where are the 6 terms? So WD.
They're all there. No,
Yeah,
no,
they're
those
all
are
the same.
those are the same at the tops. Those 6 are the same at the top.
Yeah, so I probably should have boxed these in green, right? Because that's the green.
Those
yeah?
are the legit ones. Like the other ones.
Green. They're all blue.
The
Like
green.
the other ones are the irrelevant ones.
And then these are the blue ones,
No, I
yeah?
was gonna say that.
You beat you to it, so therefore you're irrelevant.
I was gonna say that about myself, but okay.
Okay, so the WD on
But I beat you
DU
to
is
it.
here, yeah? Yeah?
Yeah.
So let's tick them off, okay?
Yeah.
So that's here,
Ooh.
yeah? UE on EV is here, yeah? See that?
Yo.
VA on AW is here, yeah? UF on FV.
This Menalaus Theorem is actually giving me cancer.
I don't know if that's, what does that mean?
It's bad.
It's not good with the corona, is it? No, stop it. Okay, VB on BW.
Michael's life is valuable.
What? You don't die from corona?
Yeah, I know. But he doesn't want it anyway. His life is too valuable to waste.
What? No,
If you don't die.
Whoa, hold on. It doesn't mean it doesn't cost anything, right?
no,
Yeah.
it's like getting the flu.
No, but if I get coronavirus,
You
it's
just
like
get sick. You take Panadol and then.
I'm like gonna be treated like a vampire for like the next.
Oh yeah, now I know.
No, only because because it's so infectious, not because it actually damages your heart really badly.
That's the same
I-
infectivity as.
I think
flu as
it's
well.
sort of damaging to your health if no one will want to have contact with you.
It
Yeah,
damages
it
your
would be
mental health.
sad.
Yeah, it does more damage to your health.
What if you don't want to talk to people anyway?
True. Just
Corona-
can't run
no,
out
actually,
of mine.
Increase my mental health.
Corona's
Exactly.
perfect for you, Kyle.
if you're like a sociopath,
Hey, take a
you
photo
actually-
with me and you. We got this.
Why?
And no.
Alright. Oh, so we good? So all the 6 things in blue, yeah, cancel. Can you see that?
Yeah.
Yes, I do.
So if you multiply all this together, you get exactly all the terms here, right?
That's kind.
So if you divide it by -1 twice, it's the same as dividing by 1, yeah?
Yeah.
Yeah.
Ow. I said that.
Oh, we're done.
No, come on, we get it. Like,
So those 3 are equal
Does
to
that make sense?
my. Why? Like,
So-
why?
In principle, okay, after we've gone through the Pappus Theorem chapter, right? The Pappus Theorem chapter exercises are kind of like automatically
What's this bad
set
boy?
for homework, except there's no such thing as homework, okay? That make sense?
Collapse.
So you can choose to look at it at home, or you can choose to look at it when you get here next, okay? But like it makes sense if you learn this chapter to consolidate it with the chapter exercises, yeah? Okay.
Okay, let's do one exercise this week.
So the
On
thing
this.
about the like even
I'm gonna do exercise 1.
so the exercise today was to kind of like assume Menalaus without necessarily understanding it and try to use it. Yeah, that was one of the exercises. Yeah, but if you use it enough, you're kind of starting to understand it anyway. Now it's like we understand Pappus' theorem relative to Menalaus. Yeah.
wow.
Yeah.
Okay. I don't think I was gonna go through perspective and decide,
It's not an
but
exercise.
you guys don't make me think I can get through it.
Go, Michael. You can do it. Let's go,
I
Michael.
believe.
Let's go, Michael.
But it's kind of interesting that chapter, like the maths behind those chapters are designed. Are came up by architects. Yeah.
What?
Because it's kind of like they're trying to build their houses nice. Yeah.
Just make it want to know if it's like a level.
dude, why can't you just build their houses?
You have the
Why
book,
not,
why
not
like,
who cares?
I didn't even know. Yeah, okay, yeah, why am I? To read it later.
Well, it might be important that like one of the pillars matches
Why
up
do
to
you
the
have a
other pillar.
book?
No, no, no.
Oh.
When I don't have Onion.
Oh.
But I have an online book, I mean, how?
Yeah. You
No,
just
no, to match the photo.